Welcome to JD's Prep. Here we review a 5-part question. Let's first take a look at the scenario. Here we're looking at white nose syndrome found in bats. White nose syndrome, or WNS, is a disease found in bats. The disease, first detected in bats during the winter of 2006, is characterized by the appearance of a white fungus on the nose, skin, and wings of some bats, which live in and around caves and mines. It affects the cycle of hibernation and is responsible for the deaths of large numbers of bats of certain species. In some areas, 80 to 90% of bats have died. Not all bats in the area are affected, and certain bats that are susceptible in one area are not affected in other areas. The roles of temperature and humidity in the environment of the bats are two of the many factors being investigated to help control the disease. Over the past few years, the Conserve Wildlife Foundation of New Jersey conducted summer bat counts of 2 bat species at 22 different sites, totaled the numbers, and reported the results. The approximate number of bats counted to the nearest 100 are listed in the table below. And here we can see our summer bat count results. And this shows the total number of bats that were received over 5 years, which were 2009, 2010, 2011, 2012, and 2013. And the 2 species of bats that we looked at were the big brown bats and the little brown bats. Let's take a look at the first part of the problem. It's asking us to mark an appropriate scale without any breaks in data on the axis labeled number of bats. And this is going to be referring to the chart that we are going to be given. Let's first think about how we can create our scale on the axis labeled number of bats. We have to consider all of the values that are listed in this chart. What I recommend is find the smallest number out of all the data, which is 300 in this case, and the largest number out of all the data, which happens to be 6,100. If we take 6,100 and subtract 300, we get 5,800. If you count the number of lines, including the very bottom line, you will get 21 lines. So what I recommend is dividing it by 21 to see roughly how many increments we should make our lines. Since our number comes out to approximately 276, let's round up and call it an even 300. Since we're going to have to make even lines going from 300 to roughly 6,100. It probably won't be exactly 6,100, but at least we'll get enough even increments on the given number of lines on our graph. Next, the question is asking us to plot the data for big brown bats on the grid, connect the points, and surround each point with a small circle. And here's an example of how they want us to do it for the big brown bats. The next part tells us to plot the data for little brown bats on the grid, connect the points, and surround each point with the small triangle. And this will be for the little brown bats. Recall that we're going to be using 300 as our scale. So we're going to count by 300s to be able to plot all of our given data on the next slide. Let's start plotting our graph using our determined increments. Remember, we're going to count by 300s. Now that we have our axes labeled for a number of bats in even 300 increments, let's start plotting the data for big brown bats, which, as you can see from this side key, we're going to use circles for big brown bats. But first, let's plot the points. So I'm going to use two different colors. For big brown bats, we're going to plot 900 at 2009, 1000 at 2010, which should be approximately over here, 1000 for 2011, 1000 for 2012, and actually this should be here, and 1,300 at 2013. So just a little bit above 2012. And we're going to circle them for the big brown bats. And let's connect the dots. And let's follow a similar procedure for little brown bats, which we're going to use triangles for them. But first, let's plot the points. In 2009, there were 6,100 little brown bats counted. In 2010, there were 1,700 little brown bats counted. In 2011, there were 500 little brown bats. In 2012, there were 400. And in 2013, there were 300 little brown bats. Now let's mark them with the triangle. And connect their dots. Now that we've completed those 3 parts, let's move on to the next question. Biologists in New York and Vermont have noted that in recent years, a higher percentage of the little brown bats are now surviving. Which statement best explains this increased survival rate? 1. A few of the bats possessed an immunity to the white nose syndrome disease and produced offspring that were immune. 2. The bats needed to reproduce in greater numbers, otherwise they would have died out completely. 3. The people that performed the recent counts did not identify the bats correctly and were counting bats of a different species. Or 4. The original decline in the bat population due to white nose syndrome was a natural occurrence and is part of a natural cycle. Because we're looking at why the higher percentage of the little brown bat is surviving, we want to know what happened to increase the survival rate. Well, of those little brown bats that survive, they had some sort of immunity to white nose syndrome. And because they had that immunity, they were able to produce offspring that were also immune. Therefore, this is the reason of why they were able to survive. And our final answer is option 1. Now let's move on to the last part. Conservation groups have promoted the building and placing of bat houses in areas thought to be most suitable for bat populations. Explain why this might have a positive effect on the control of white nose syndrome in bats. Some of the things that you might want to explain are that they provide a safe environment for those populations that are surviving. You also want to mention that bats can use these boxes to raise their young. And lastly, these boxes can also provide areas for resting. And this is important because white nose syndrome causes bats to fly around during the day when they should really be resting. Thanks for visiting JD's Prep.